Corey Berg and his son, or by Kenny Berg and Corey Berg, his son runs the company now, so it is a family-owned business. And we use the molasses to feed biology in the cow's stomach. And now we use that molasses to feed the biology in the soil. So we've been feeding biology for a really long time, and we're pretty good at it. So we have over 40 million gallons of storage for molasses, and we actually added 10 million gallons in the last year and a half here. So when they start to harvest the cane, they extract the sugar, they have all this molasses, and we have to store it until we can ship it to the rest of the places. This is shows all the different places that we have our plants and locations, and these stars are actually where we make the fertilizer. So we have dedicated manufacturing for feed and then for fertilizer. So they don't mix, and they don't mix on our trucks, and we filter it 3 times before it ever gets to your farm. So we make a lot of effort to make a fertilizer that you guys can use relatively easily. This is what the sugar cane looks like growing, and this is their combine to harvest it. They cut off the top leaves, they bring in the billets, and they chop it up, and they extract the sugar out of it, and then we use the molasses to feed the microbes. They plant the billets in there, and they can get like a crop like 3 to 5 years off one planting. And then they rotate it with like rye or something like that. QLF has an extensive delivery system. We have over 130 trucks on the roads. We have barges and rails that we ship the molasses to all our plants that then we can make the feed or the fertilizer. This takes quite a bit of effort right there. We have people dedicated just to moving rail cars, because it takes quite a bit to move 40 million gallons of molasses around. So QLF, this is the products that we offer. So we have LCBF Boost, which is our concentrate. So this goes in with your other fertilizers, with the spray. It's meant to be very versatile, and it feeds biology really well. So it has a 4032S, and we'll get into some of the places that we really like to use it. But that, in essence, Boost is like it goes with just about anything. The 721-3 MKP starter, that is our corn starter that goes in furrow. It's really good at feeding the biology and then bringing plant nutrition for that young seedling. So we've kind of built like an all-in-one package that you get a great starter. The MKP part of it, that's the monopotassium phosphate. It's really seed safe. It's really helpful for the biology. So we built that as a standalone starter. Amino 15 has a 1501. It's a really safe foliar nitrogen. We utilize urea and amino acids as nitrogen sources. What's advantageous about those are bringing more carbon sources. They're actually more efficient for the plant to take in those nitrogen sources. And I'll show you a little bit later, but like in essence, like urea and amino acids, they can be more efficient at converting nitrogen into amino acids. So it takes less energy and less water. So that's why we utilize that. And actually, I got some data to show that actually PTI has trialed that on their farms as well. And then we have the 555, which is a 555, also utilizes the MKP. And it's a balanced foliar nutrition. So if you're looking to bump your plants for foliar nutrition, that's what the 555 does for us. So we do carry Calpac and Calpac Max. They're a liquid seaweed extract. The difference between Calpac and Calpac Max is the Max is meant for seed treatment. So it's concentrated. You're able to use it as a seed treatment. You get that plant hormone right on that seed when it gets started. Helps with root development, getting a better root system started right away. We do have our micronutrient add-ons. We have corn spike, which is for in-furrow, mainly used with 721-3. And then we do have Powerade, which has a foliar micronutrient blend. And that goes with almost any, whether it's Boost, Amino, or 555, we can add that in as well. And then we do have TerraFed, which is like the organic version of Boost. So if you're looking for an organic product, TerraFed and Calpac are both certified organic. So that's just kind of a quick overview of what we do offer. So this is where I get to work. This was an old supper pub that we converted into a research center. And what I mainly get to work with is a growth chamber, the greenhouse, and the tank farm. And so in here I can do a lot of different germination studies. So here's a picture of inside. So I can control the light, temperature, the humidity, and I can control it. And so like when I use like a starter, I can use different combinations and see how that actually affects how that seed germinates. So like salt index gives you an idea, but this is actually a better way to actually test how much product you can put on before he starts to hurt the seed, how little we can use to get a response to. Here's what the greenhouse looks like. That is always changing. That's not what it currently looks like. And then like the tank farm, so when I was first started, we were challenged like, what's the best tank setup? And there's 15-degree cone bottoms, there's 30-degree cone bottoms, and there's flat bottoms. I prefer cone bottom, but they are a little more expensive, but they're a little easier to circulate. But we do have a system called a mixing eductor that we can actually add onto a tank, and even like a flat bottom, it actually stirs it like a tornado in there. So it does a really good job keeping everything suspended, and that's a good way to mix it up before you use it. The cone bottom, you can actually take like an air compressor air, and at just 30 psi, you can actually get that bubble, and it makes it really easy to use. So the other thing, having like air there, you can actually like push through your line, so you don't have product sitting in there. You have a long hose to your planter, you don't have to carry around a big heavy hose. So we do actually have tanks set up over there if you guys wanted to look at what a setup looks like. So we bring more than just sugar. Sometimes sugar is easier to talk about, and Glenn will talk about sugar just a little bit today. So there's so much more in the molasses and like that balance of it really helps feed my microbes. So we like to show like we bring more than just sugar, and we bring some attributes with our products that helps like within your farming operations. So here's a nutrient profile of just the molasses. You can see here there's a lot of micronutrients, and again, they're in a really nice balance because they came from a plant. So they're already kind of like balanced out for us naturally, and they're also plant available. If you want to learn a little bit more about molasses, there's in one of your handouts there, we have what's called Molasses 101, and it can take you through some interesting facts about molasses. One thing that I'll point out is that we do use TSI, so if you look at our sugar content, we do measure it by TSI. And what does TSI mean? It's total sugars that's invert. So what's that mean? So basically it's measuring 3 different sugars: fructose, glucose, and sucrose. So we're actually measuring what sugar is in there, and that's the number that we give you. Not everybody will use that as a form of measuring sugar, but it's a little bit more precise. So if you're trying to compare sugars, make sure that you get TSI versus TSI.
Do you have the last slide with all the nutrient value? Is that in here somewhere?
I believe so, if I remember. There's a handout, I believe. And I think it's in, forgive me for this one right here, I believe.
Yeah, we'll find it, Anthony.
Thank you.
I'll keep rolling, bro. Okay. Glenn's gonna touch on this. I'm gonna skip it so I don't give you the answer. But, so this is Boost. It's a 4032S, and one of the places that we really like to use it, part of it is if you measure the PM, it's around 7.5, whether it's 28 or 32. But if we take 10% out and put 10% Boost in there, we can drop that pH. We drop it to 4.6 in this particular example. What that does is help us keep volatility. Page 11 is the molasses profile. All right. Page 11, the nutrient profile for the molasses in there. If you didn't find it.
In the grower's guidebook.
Grower's guidebook. So we take 10% out, put 10% Boost in there, and we can lower that pH. Also with the carbon in our product, we help complex the nitrogen. So you might be used to the term stabilizing nitrogen. We don't like to use that word because by definition, stabilizing nitrogen, we actually interfere with biology in a negative way to stop the nitrogen process. So we complex it, we add carbon to it so that it isn't able to escape, and it helps it from escaping through volatility or through leaching. If you tie that carbon to it, it's less likely to get away. If you have never smelled UAN before, smell it and then you can put the Boost in it, and you can't smell the UAN anymore. This is actually a gas meter that measures the ammonia coming off. So some people are saying, well, the molasses is just covering up the smell. But this meter actually measures the ammonia, and it is showing us that Boost will actually help keep that nitrogen there. So I'm going to play this video for you, but I'm going to, So this bottom number is what you wanna pay attention to, that is your ammonia number, and it's starting off at 70. And when I put the nitrogen inhibitors in there, it's gonna go down a little bit, then it'll get back up to 70. On this one, we were using humic acid, it's 12%, and it's gonna get down to like 50, and with boost, we'll get below 10. So, your nose can actually pick up 30 parts per million. If it's over 30 parts per million of ammonia, that's what our nose can pick up. So when you actually put boost and the nitrogen in there, it drops below that, and our nose can't pick it up anymore. So again, pay attention to the circle in red there, like pay attention to that number right there. So it's not covering up smell, it's actually adding carbon that helps complex that nitrogen in there. So, the other thing that lowering pH does, if you look here, and this is from the University of Purdue, you have your herbicide, it increases the half-life. So if you had a pH of 7, your herbicide has like 17 hours before half of it is ineffective. If you can lower that pH to 5, you have 16 days before half of it is ineffective. So lowering pH actually makes those herbicides, fungicides more stable and last longer. So the other thing we did, like with boost and UN, is we looked at like nitrate leaching. So it's the other way that we lose nitrogen, it's through the soil. So if we can tie carbon to it or actually get it into bug bodies, we can actually turn that nitrogen into organic forms of nitrogen, so we can keep it there. So we had a drain tiles in this study, and we measured all the rainfall that went through it, and we measured the nitrates that went in the water. So we actually put out 20 pounds less of nitrogen. We had 17% less nitrates that we detected in the water. We actually increased the bushels. We increased the yield. What that tells us is that we're actually getting more nitrogen into the plant. We're getting more amino acids built with using less nitrogen, but we're adding that carbon, feeding that biology. So here's some pictures of like where we put 32 with boost. This is just 32% alone. You can see like the more consistent green color. And then here's a picture of like ears that we picked off those different fields. I'm gonna breeze over this really fast and we can go back to it, but we're looking at different ways of looking how biology responds. Like when we put boost with UN, and we're seeing that phosphorus and nitrogen is more available. This is another study I'm actually doing on my own farm, but we've actually been putting boost with 32% and over wintering it. So most of the time, if you have it on your farm, you gotta cut it to 28. And I'm putting boost with it. This will be the third year. This will be a really good test. This year's been a lot colder than most. But I put 32 in my tank, and I put boost in at 15% and over winter. So this spring I'll find out if it's salted out or not. The last 2 years, it's been just fine. It's worked really, really well. But what I use, that's where actually the mixing eductor is. Put a tank of boost there, and I put it in the 32 and it'll swirl it. It looks just like a heat cloud going in there. So it'll be something to find out how this spring works out for it. So something to look forward to. Either I'm going to be really happy or I'm going to be mad at myself. So you can see it mixes really, really well with UAN. So in part of that, like when we mix that with the UAN, like it's buffering the salts that are in the UAN, and so we create a better environment for that soil biology. And you guys, pretty much all this stuff that I went through is in a nice little handout in this on your table there. The not so secret reasons of why you should be using boost with UAN. So if you forgot everything that I just told you, you can go back in that pamphlet and it'll reiterate what I just said. So. Nitrogen. Can anybody explain nitrogen to me? If someone, like a little kid or somebody asks you, what is nitrogen? How would you explain nitrogen to someone? Kind of hard to do, right? What does nitrogen do for us? Is maybe an easier way to explain it. Why do you guys buy nitrogen? Why do you put it out?
Protein.
protein. Yep, and so the plant takes it up, builds amino acids, and builds protein. So carbon, I'm gonna talk about that a little bit more today too, but carbon, again, trying to explain what carbon is a little hard, but what it is for us is really awesome. So it makes it really, it's like it's a foundation of building blocks for life. So it makes really good association with all of our nutrients, and it's at the core of everything we do. You're gonna find out how much plants are made up of carbon, but does anybody have a guess how much carbon is in us? If you had to guess, throw out a number. 10%, 20, 30? 18%. Humans are like roughly 18% carbon. You'll have to find out from Glenn how much is in a plant. It's 18%. He's gonna get into that more. I'm gonna touch on herbicide metabolism. How much time I got, Bob?
About 10 minutes.
Okay, here we go. So, herbicide, metabolizing herbicide. So when we put boost with our spray mixes, even though your plant has a genetic capability of processing that herbicide, it still takes energy. And that energy, they have to take that herbicide in, they have to break it apart, they have to bind it, and then get rid of it. So an easier way to think about it if an intruder came into your house, they have a knife, they come in, you have to disarm the intruder. So how does the plant disarm an intruder? They use chemicals that hydrolyze the molecules, and basically they can change one ion, a chloride to hydroxide, and they can actually make it 1,000 times less toxic. So they use that to make it less toxic. That's how they disarm the intruder. The second thing they do is they bind the intruder. So we get the intruder disarmed, we're going to handcuff them. How does the plant handcuff the herbicide? It uses sugars and amino acids to do that. And why does it do that? It's so when it's taken it to a different place, that it can't interact with the plant, it can't hurt it. So and the third thing that it does is it puts it in jail. Where's the plant jail? It's in the vacuole. There's like these little places in the cell. They're like a closet. It throws it in there. Or they can throw them like in the cellulose into the cell. So it gets it into a spot where it can't do any damage to it. So that's how a plant metabolizes herbicide. And I'll show you a picture, and that's where we first started seeing it. Like when we sprayed with it, we'd see that our plants were getting through that stress period a lot quicker. The other thing that adding boost to your tank can do, and even amino 15 to some degree, is we can increase your sprayer performance. What that red circle shows us is that how many of the droplets in that spray are 150 microns or less. What does that mean? Anything that's less than 150 is going to drift away. So if we can keep those droplets above 150, we're going to hit our target. When we add a gallon of boost, we drop it from like 32% of those droplets drifting to 27, and then down to less than 25. So this was done in a drift tunnel in Nebraska, and this actually has a statistical difference that 1 gallon is better than nothing, and 2 gallons is better than 1 gallon. So we can make more droplets hit your target. The other part of it was to talk about droplet size. We don't want like a whole bunch of really big droplets. We don't want a whole bunch of little droplets. We want them like in that range where they hit their target and they're not drifting away. What relative span tells us is that how uniform those droplets are. So if we have more uniform droplets and they're in the right size, we hit our target and it stays there. We get better coverage. So that's what it's telling us there. Here's a picture of like water on a leaf surface. This is boost. So this is showing us surface tension. If we have high surface tension, that droplet looks like that on a leaf. How much contact does that have with that leaf versus something that has low surface tension? When we have low surface tension, we actually have more surface area contact, and we can actually get it into the leaf better. The other part of that too is it's a natural humectant, and what does that mean? As that droplet sits on that leaf, if it stays hydrated and slowly dehydrates, it actually gets more of that product absorbed into the plant. So whether you have a herbicide or a foliar nutrition, if that droplet can survive long and dehydrate slowly, you actually get more product into the leaf. I'm going to skip that. That's videos of it going through planes and drones. We actually could run amino 15 straight through a drone. So I'm going to touch on amino 15. There's 1 pound of sugar in there versus 3.3 pounds of boost. but again, we're using like those, urea and amino forms of nitrogen, which are more efficient. I'm gonna skip to, basically, plants have protein pumps that they can actually take in urea or amino forms of nitrogen, organic forms of nitrogen. And so when they do that, it actually takes them less energy to convert into an amino acid. So for instance, this is the process for nitrate to actually get to amino acid. Look at how many more steps are there versus ammonium. And then urea is even less, and amino is even less than that. This takes 6 times more energy to get to an amino acid than it does for ammonium. So that's how it's more energetically efficient at converting into amino acids. So different forms of nitrogen have their pros and cons, but that's why we utilize those in amino 15 to be more efficient, especially when it gets into the reproductive stages of it. We won't want it spending a lot of energy growing. We want it more energy into its reproductive. The other part about that is converting into those proteins takes all these micronutrients. So part of like, when I talked about that nutrient profile molasses, we have that in our products. And so we help with converting those nitrogen into the amino acids. I'll get into, here's the study that was done at PTI. On average, over 3 years, we increased our yield to 8 bushels. And in these trials, we used 5 gallons the acre, and that was applied with a fungicide. And then we actually had 3 trials here down in Iowa, and I'm just going to summarize it up for you. With the amino-treated acres, we had 234 bushels per acre. With the untreated, they had 218 bushels per acre. So again, this was put on with the fungicide, and this was put on at 2 gallons the acre. But overall, on an average of 3 different trials, just farm trials, we had a 16 bushel average. I wouldn't say that's completely normal, like it happened on there, but I would say that 8 bushels is a little closer to what we normally see. So that's in a nutshell what we do and what we can. We feed biology and we bring these other attributes with our products. So we work well with fertilizers as well. So, any questions on that?
Well, this ties up the ammonium side and the nitrogen. How does that release it back? Because we know the ammonium is the plant, it goes into the plant to form the life into the plant.
So so ammonia is one of the forms. Ammonium is another form. So ammonia is actually the gas form, ammonia.
Yeah.
And so it actually can go in different forms. And so biology, whether you have it in organic forms, they can actually get in the plant as well. So if you can keep the nitrogen there in the soil versus volatilizing off, that's what it's doing. So does that make sense? Sort of. Yeah, nitrogen gets a little, I can show you on my computer, like there's different forms, and I can show you like which forms a plant can take up and how we can keep it there in the soil, basically.
Well, just to add to that, both plants and microbes can work with ammonium nitrogen very efficiently. So you gotta remember that the microbes might have their say in it, but that's okay. We keep showing yield data that says it's okay if the bugs cycle that nitrogen through them. And it's less prone to leaching ammonium nitrogen.
Yeah, so, yeah, like I said, I could show you like when you can convert nitrogen into organic forms, the plants can take some of that up, but like it gets into a bug body and then it becomes available for a plant that way as well. So the plants that can take up more forms of nitrogen than what we've been necessarily taught, they're just better at taking up ammonia and ammonium because they're more water movable. And so they can move through the nitrogen profile better versus like those other forms, like the root has to find them. So it tends to take up more of those other forms. So, yeah, I know it's a little different than what we've been taught, so, yes.
For boost, what's the proper usage rate for like in furrow, 2x2s? The ratios with nitrogen, the foliar, what have you found? Because we've been using it for quite a few years, but I want to know what your research on.
I'm gonna tell you it depends. It's, I would rather find out like what you're doing on your farm and tell you, because everybody's just a little bit different. But in general, 1 to 2 gallons in furrow, depends on, again, if you're putting it with another fertilizer, if you have other things that are going in. With the nitrogen, we've seen a lot of stuff with like a 10% replacement. So let's just say you're putting out 20 gallons, right? You take out 2 gallons of UAN, you put 2 gallons of boost in. We've actually seen a little bit better with a little bit higher, but we kind of keep it at there, just, it makes more sense logistics, it's easier for math. I don't know if there's any other rates. 1 to 2 gallons, like in a herbicide pass, again, it depends a little bit like how complicated your mixes are. And that's something else I'll say too, like let's just say you wanna, you're like, hey, will it work with this mix? If you get your recipe to one of us, we built a jar testing program. So you can put in, I use this at a quart, I use this at a gallon, I use this at 3 gallons, and I'm spraying 15 gallons an acre. It'll spit out what we need to put in for that jar test. It makes the math a lot easier for us. And so like if you're willing to get that recipe, like we gladly jar test with you, and we're actually tracking that database too, so that we can be like, hey, it worked here, like here, not so good, like just trying to get a better database of what all we can do, so.
You're done.
I'm done.
Got one more question for you.
Oh, fire away.
What is it not mixed well with? Like, we use everything from, I mean, you name it.
Yep. I would say I've seen more of an issue when you have a complicated mix and not enough water. So we tend to like, let's just say like you should be spraying 20 gallons, 15, whatever your theory is on that. There's some guys that'll get down to 10. Then you have like 6 different chemicals in there. You gotta have enough water to keep everything happy, and that's what I've seen more of an issue with versus like just any one particular thing. It's been more of like the combination of stuff, so.
Viscosity is more the problem.
It's actually, I think there's not enough water to keep everything, so everything's a concentrate. So when you put it in, you gotta have enough water to keep it happy, for lack of better terms, but like, when you put it in 15 gallons of water, like you don't see any different in viscosity. Actually, when you put it with UAN, I mean, this stuff looks like water. Like, so the viscosity doesn't change that much. By itself, yeah, it's a little bit thicker, but when you put it in that tank, like it doesn't change the viscosity of it. It just, there's not enough water to like be a carrier basically, so.
Last question.
Yeah, no, yeah.
So I use Green Lightning and 7 vendors that use Green Lightning. And, I believe on the label it says like don't pre-mix with water. So one thing I like to do is stabilize that because it's a nitrate form.
Yep.
What, have you jar tested that over time? What have you seen with that?
So I've jar tested, I haven't looked at it over a long period of time. I did, when I put it on the plants, I did see like there was an increase when we had the Green Lightning and the boost, like they worked well together in the plant. They mixed well, but I didn't look at how long. There's enough water, like if you were just to mix boost and Green Lightning, I would guess you might have 5 days before you start growing biology, but I don't.
That's not what I found in my jar testing. Same with humans.
Yeah, so and then humics vary so much too, like the source and how they extract it. Like, that's a whole nother ballgame.
I know.
Yeah. And I guess one other thing I'll add too, like there's different carbon sources, like a humic or fulvic. They don't necessarily feed biology very well at all. Like ours is available carbon that feeds biology. Those other carbon sources maybe do more for like soil amendment type of stuff. And like a fulvic is better at getting like in a plant leaf, but we do have fulvic properties to our products. So all I know that we got here. If you got any more questions, feel free to, I'll be around, so.
You're up, Cap.
It works. That may not mean anything to anybody. Bob has introduced me as a disruptor. What does that mean? When the university professors and the big companies get up and start telling us things, I question authority and I challenge the status quo. What I mean by that is I was at a seminar many years ago and a geneticist from South Dakota State University was talking about all of the traits in corn. And he was going in great depth, and he was a PhD. He had more letters behind his name than I had in my name, my last name being Rabenburg. This guy was educated. So he's going into all this detail with the traits and the genetics and all the fantastic science and the wonderful chemistry, and the bald guy's hand goes up. I say, why does corn dent? And he doesn't know how to respond. And so he asks the question back, buying a second at a time. He goes, was your question, why does corn dent? Yeah. A little bit more of a pause. Another stall tactic. Well, that's an interesting question. I've never had that asked. Why would you ask that? And he's trying to gain control by asking questions. Just like when we came home too late as kids, and your mommy or dad said, "Did you have a curfew? Did we tell you what time we were supposed to be home? Do you think you don't have to listen to us?" You know all the questions. They had control because they were asking the questions. So finally he says, "A kernel of corn shrinks and dents because of the natural maturing process." Hand goes up again. And he's not impressed. He's like, "Oh. Shit, popcorn doesn't dent. Flint corn, Indian corn doesn't dent. Could it possibly be because they haven't been genetically screwed with?" Good statement. Any other questions? Didn't want to hear from me. My point being is we've been fed a lot of information that has been very financially advantageous to a lot of other companies. And we're getting, and I say we because I'm a farmer as well in South Dakota, an organic farmer, we have been given the information that the universities have gotten paid very well to represent. It isn't the truth. It isn't the whole truth, but they've given us a sliver of the truth. And I'll give you an example. And I want to read this so I don't get any of the numbers wrong. South Dakota State University had a foliar feeding crop removal, nutrient removal meeting. And boy, the room was packed. And the first professor gets up, he says, the need to feed. Foliar feeding that plant, knowing what that plant is made of, knowing what the nutrients that you remove in a bushel of crop is important to your survival and your future success. And everybody gets a warm feeling like, oh, this is awesome. And he stands up and sticks his chest out. He says, a bushel of soybeans will remove nutrients from your field. And that one bushel of soybean will remove 4.9 pounds of nitrogen. And everybody starts writing that down. He says that same bushel of soybeans will remove 1.1 pounds of phosphorus. And they're writing that down. And he says that same bushel will remove 2.4 pounds of potassium and 0.4 of a pound of sulfur. And I'm writing them down right with them. And I'm adding them up. I raise my hand. This guy doesn't know me yet. Question! I said, help me out. Add these up. Knowing what the removal is. You got it. Take it times how many bushels you want. Away we go. He says, that man gets it. He understands it. That guy's hand goes up again. It's like, what's a bushel of soybeans weigh? Long pause. I said, can we just say 60 pounds? That's fair. 60 pounds of soybeans, what you gave us isn't even 9 pounds worth. Isn't even 15% of a weight of a bushel of soybeans. What's the rest? Just a great question. Any other questions? I am becoming a disruptor. I'm going to say things today that you will probably agree with, and that's okay. I'm going to say things today that you're going to do that. Yeah, I don't know about that. And I'm going to say things today that you're like, that guy was dumber than he was big. There is no way that is true. All of those are good. I've given you a sheet, that lime green colored sheet, that I'm going to give you the information that the few of us that are old enough to remember Paul Harvey, remember what he gave us? The rest of the story. Thank you. So no matter what crop you're growing, whether you're an organic or a conventional or a GMO, whatever it may be, this information will apply to you. It's going to be evaluation. We're going to jump in and out of a lot of different sciences. Now, when a lot of people start talking chemistry or physiology, a lot of guys just go, oh, shutting down. You don't have to be a chemist to understand chemistry. Give you a different version. You don't have to be a chef to make a sandwich. You can survive. I'm not a chemist and I don't want to be. But we're going to get into chemistry, physiology in the plant, physiology in the soil on the level that it's like coffee shop or dinner talk. So when we look at a plant, no matter what plant you're growing, out in the field, that plant wants to do something. And everybody may have a different answer with what that plant wants to do, but that plant wants to push its roots out, lay its leaves out, gather some sunshine, and through photosynthesis, I can't do a PowerPoint because I can't multitask. Hitting the button and trying to talk, I'll fall down and probably swallow my tongue. The plant wants to make sugar. Photosynthesis, sunlight, water, minerals. Photosynthesis. They won't talk to you about this because the more you understand it, the lower your input goes. Now, if we had a chemist in the room, he'd say sugar. Plants make sugar. But chemists think differently than we do. They were some of the kids we picked on in high school and college, but they're the smart guys. But if we ask the chemist, what is really the components of sugar? Because if you want your plant to make sugar, this sugar is the plant's fuel. This sugar is the plant's energy. This sugar is the plant's immunity against diseases, against insects, against lower growing plants that they call weeds. While we're on that, anybody have a professor say a weed is just a plant growing out of place? Sounds like kind of a BS answer to me, but we'll go with it. A weed is growing exactly where it's supposed to. And that weed is growing right where it's supposed to because there's a deficiency of sugar in the soil. Nobody talks about sugar in the soil. That's where the comment, guy from South Dakota must have got some paint chips in his formula when he was a kid. He's not thinking straight. When we look at the production of sugar, this plant will make a bunch of sugar during the day, hopefully a lot of it, and at night, when the sun goes down, it'll push that sugar as a root exudate to feed the microbes. The microbes love this sugar and mineral, kind of like molasses. The microbes love this because then they start mining and breaking things down and fixing the soil and correcting deficiencies and making nutrients available that many companies don't want you to know about. So when we're looking at the sugar, there's 3 components that make up sugar. Carbon, in fact there's 6 of them. Hydrogen and oxygen. Yeah, big deal, who cares? The numbers that the professor gave in South Dakota on the crop removal and the biggest limiting factor to yield, he left this out, and this makes up the majority of your plant. If you see your soil lumping, clumping, clotting, caking, given any kind of bad personality, you have a deficiency of this, And if this is deficient, the microbes are deficient, and all of a sudden now you get to buy more inputs. Welcome to farming in North America. When you look at a soil test, the soil test is represented in the top left-hand part of the soil. This sheet we put together quite a few years ago. I was asked to speak out in Sacramento, California at Southern California University on soil health and what is healthy soil. First thing we should define is what's the definition of healthy. My definition may be different than yours. Being from South Dakota, simple, straightforward, and common sense. Without disease and without impairment. Makes sense? You guys may have better definitions than I do. So when we're looking at healthy soil, kind of goes along with our company name. Soil Works. Some guys have said, Soil Works. Why would you call a company Soil Works? It's like, well, when your soil works, you don't have to buy as much fertilizer. If you have your minerals in alignment, your soil will work better. If the microbes in the soil can breathe, eat, and party and reproduce, your soil works even better. The better your soil works, the lower your inputs are. The better your soil works, the higher the sugar content of the plant. When your soil is working, you don't need fungicides. You will need less herbicides, and you will not need insecticides. Oh, big statement from a bald guy. So let's jump into it. If we're looking at healthy soil, the largest increment of healthy soil, if you guys would like to write this down, this is proof and written information that you can take to your agronomist, your consultants, your fertilizer guy, your seed guy, and you can ask them, these numbers right? And if he says yes, you can say, why haven't you given them to us before? It's not his fault, it's not her fault. This is the system that has kept us in the dark, and we've been told what makes them more money than us. So most guys will soil test, and they'll look at their soil test minerals, and they'll look at those minerals, and they'll talk about them, and they'll work on them, and on that top left pie chart, 45% of your soil is made up by soil minerals. If you get your soil test right, you will get a 45% grade on harvest. Not really good odds. Because your soil test, does it talk about carbon? Does it give you an oxygen number? Because this is the majority of a healthy plant. Healthy plant being a plant without disease or without impairment. And it's wonderful to listen to the technology with precision planting and all the awesome stuff that goes into it. But our dads and granddads didn't have any of that. And they may have been planting a healthier seed in healthier soil. Looking at the soil. Everybody's talking about soil organic matter. Now, don't kill the messenger, but all the no-till companies will say you need to have that soil armor on the top of that soil. You need to protect that soil. You need to have that there. That residue, that fodder, that soil organic matter that shows up on your soil test may not be the number that they're letting you think it is. They give us a number and they say your soil organic matter needs to be 5%. And that's that light sliver on the top. And they say if you reach 5% soil organic matter, you have achieved a pinnacle of success. Does anybody have an exact formula and the ingredients that make up soil organic matter? They'll say, well, there's some carbon in there, there's some nitrogen, there may be some phosphorus, there's this, there's that. But we really can't tell you what's in it. But even though they can't tell us what's in it, this is how much of it you need. Okay, makes sense. When I'm telling you the plant is made up the majority of sugar, I'll tell you exactly what the ingredients are. Now on your soil test, pH over 7, you will see on his soil test on the base saturation, and the base saturation, Dr. Albrecht would talk about this many years ago, and let's say that this notebook is the clay particle. And what he would describe the base saturation is he says there's 100 parking spots around this clay particle. And these can be all different shapes, sizes, and there's a positive charge on the flat surface, and there's a negative charge on the edge. And he says, with these 100 parking spots, I'd like to have 68 of them, or 70 or 72, be calcium. Base saturation of calcium. That is the beginning structure of the foundation that you build on. And he says, if you have 68, 70, 72 parking spots with calcium, you want 12 or 13 parking spots with magnesium. And then he will talk about potassium. And he'll say there's a range, 2 to 5% potassium. Say, what's the range? If you're growing non-genetically modified annual crops, or a perennial grass, or an alfalfa, you want 2% potassium. If you're growing a tree crop, or a GMO, probably going to want closer to 5. Here comes the bad news, and please don't kill the messenger. If anybody took any genetics, or you're a geneticist, when you add something in genetics, you're always going to lose something. Every time they add a gene, they're telling us how fantastic it is and how great it's going to be and how much money it's going to save us, and they're the only company and the best company, and yeah. Most cases, not always, but most cases, every time they add a gene into a genetically modified plant, the plant loses some of its sugar building ability. And every time they add a gene, most times they add a gene, loses its sugar, now you have the opportunity to buy another fungicide. Or you may need to make another pass with a herbicide. Or you now have to start spraying an insecticide or get it treated on the seed. I don't listen as well as I should have. Rabenburg, I'm German, I'm a little thick through the skull. I'm slow, but I'm consistent. But sitting in church, I've never heard the minister talk about a chemical manufacturer or a fertilizer dealer next to the Garden of Eden. From what I was raised and believed, there was a plan. He put it together in 6 days. He gave us opposable thumbs. We're in his image. We're supposed to figure this out. When we let somebody else do our thinking, they're going to give us the best thing that works for them. This is why I'm a disruptor, because this is the information that the manufacturers and big companies don't want us to know. The soil organic matter that you're looking at, that's supposed to be 5%, maybe times his residue. What do I mean by that? They have a young guy out in a pickup with a hydraulic press, bam, 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 doing different cores. And if you're like most parts of the world, it used to be, take a soil test from the best and the worst. Then it got down to 20-acre grids, and 10-acre grids, and 5-acre grids, and 2-acre grids. And if anybody listens to our neighbors in South Dakota Ag PhD, the Hefty boys, they are 180 degrees opposite from what we are, and that's okay. It's a wonderful thing. They give good information, but it's not the healthiest for our checkbook being farm for profit, healthy farmers. So when you're looking at that soil organic matter, They're punching that probe across the field, whatever grid you're looking at. The reason they're decreasing the size of the grid or increasing the samples is because your neighbor's plants aren't making enough sugar. They're not feeding the microbes aren't making the nutrients available, and you're getting micro pockets. And you're seeing different deficiencies. And we get a lot of calls in our office, and we had one call that came in, and it was two guys, two brothers that didn't make it to a meeting. They says, yeah, you sound like you're kind of a natural guy. We're GMO farmers. We thought it was going to be a waste of time. He says, can you give us any information in 5 minutes that will make us believe you're not 100% crazy? I said, do you have any soil test maps, and are they stacked that you can look to see what your fertilizer application, the seeding rate, yada, 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 the yield, and everything's stacked with everything involved? I said, you bet. We've got our computers right in front of us. I said, look at your soil tests. I said, do you have any fields that are over 7 pH or under 7? Like a 6.8 to a 7.2, so all kinds of things. Check your yield maps, your stacked maps, and look at the yield at a 7.2 pH versus a 6.8. And all of a sudden I hear one voice, son of a bitch. Another guy says, that's bullshit. I said, what are you seeing? I said, the 6.8 pH is a little bit better yield? Yeah. Why? I said, because everything that needs to happen to make this work operates in a 6.4, 6.5 soil pH. The quicker you can get your ground, and your neighbor especially with his problems, get his 6.4, 6.5 soil working, now all of a sudden we have soil works. Things are working in your benefit. If your neighbor's field is over 7, the phosphorus has very low availability. None of you have probably had a fertilizer salesman come out, look at your maps and say, well, you got some phosphorus out there, but it's not available. You guys have heard that? Or they'll say, well, you got some phosphorus out there, but it's all tied up. There's something that phosphorus needs and wants to become available. Take a big, deep breath of air, and you got the answer. Oxygen. Part of the equation. When you look at your soil test, they will give you total P. P1, P2. If you look at a tissue test, a petiole test, a sap test, depending on the lab, it may be in P04 or P2O5. What's my point? If the soil doesn't have air, i.e. oxygen, your minerals are unavailable, and now you get the opportunity to buy more. I say bull butter. Somebody already bought that phosphorus, it's there. Farm it out. Right? I don't know about you guys, but most of the places I travel across the country, prices aren't that great. Inputs are going up, and this is usually bigger than just a hobby, and now there's a little bit of pressure. Getting your soil under a 7 pH, 6.4, 6.5, don't lose your mind on a tenth of a point. Have a ballpark. The pH in farming is kind of like playing horseshoes or hand grenades. You get points for being close. Don't go crazy going, oh God, I'm a 6.6. Yeah, drive on, you're close. You got bigger fish to fry. When your pH of the soil, and pH stands for potential hydrogen. And a lot of people go, yeah. And nobody explains potential hydrogen. The bigger the number, the higher the potential, but the lower the actual. And a lot of times when I say that, I get wrinkled looks like, what the hell's he talking about? Different version, this may help. If pH stood for potential hair, I would be overselling. I'd probably, you probably can't see it in the light, but I'm starting to get a little bit of a receding hairline. So I would have a high potential hair. If your neighbor has a low pH, and that's under 6, there's other things that aren't available. They're tied up. They can't be used, and the microbes aren't happy. If your pH is below 6, you have a lot of hydrogen, too much hydrogen. And that's a problem too. The closer you can get your pH to the mid-6s, the more efficient everything will be. Talking about oxygen, almost every mineral, every element has to have oxygen to go from the plant to the soil. Which brings us back to the graph, the chart. There's 2 numbers left that make up 50%. And those 2 numbers are equally divided, if you're going to write this down, between air and water. You have to have air in your soil to have oxygen to make the nutrients available. You have to have air in your soil to make the microbes breathe. And you have to have 25% air to create the occupancy or the space to hold water. Tiling is becoming a big thing. I get it, some places you need to tile. Most places you don't need to tile because there's compaction in the soil. And it's running off the higher ground and congregating in the lower. This is a soil penetrometer, and it measures the compaction of the soil. If you haven't bought one of these, the neighbor that wasn't here, have him buy it and be kind enough to say you'll show him how to use it. And you can both use the same tool. This tool has 2 different tips. A small tip the same size as a shaft, and a big tip that you're probably not going to need, that we will only use in Arizona or in Florida in beach sand. As you're pushing this down with the correct tip, whether the soil is wet or dry, push down, not like you're pounding in a steel fence post, but push down gradually and watch the gauge. If your soil is mellow and you can push down and push down and push down and push down, and if the soil, and this is right underneath that chart, healthy soil should have between 100 and 150 psi of tension, compression, or compaction. Give you more numbers. On this gauge, it's green from 0 to 200. At 200 psi, there's something that happens. 200 psi isn't that much pressure, but when you get over 200 pounds in the soil, the microbes quit on you. I believe the microbes are union, and when they get to 200 psi, they're like, we can't work in this environment, there's too much pressure. A lot of people say, yeah, who cares about the microbes? They're kind of important because they, the aerobic, air-breathing soil microbes, breathe just like we do. They breathe in atmospheric air, and to clarify that, atmospheric air contains 78% nitrogen, 19–20% oxygen, 400 and some parts per million of CO2, and all of a sudden it's like, this is starting to make up part of the plant. If the microbes are feeling stressed with the pressure, they do not exhale like we do, and they don't exhale CO2, and that CO2 is major components for what the plant needs to make sugar. if your soil has a high pH and you have no hydrogen, you're gonna say, well, who talks about hydrogen? Well, it makes up more of the plant than nitrogen. Something they never talk about. Many years ago, my old professor, I was trained in the livestock, animal pharmaceutical, animal science end of it, and I started looking at the soil, and I was going to start going to soil seminars, and I asked my professor, I didn't even know if I know enough to ask a good question. He says, I tell you what, he says, pay attention to what they're saying, and to listen and be attentive to what they don't say. He said, I just told you I don't know anything. How do I know what they don't say? He goes, thanks for asking. Educate yourself so you know what a plant, soil, what everything is made of, so you will now know what they're not talking about, because what they're not talking about is probably what you should be interested in. The reason they're not talking about it is because somebody hasn't paid them to do the research. No company that manufactures and sells stuff is going to pay a university to show you how to buy less stuff. Yeah, sorry about that. So when we look at the soil, over 200 psi, the microbes are done. They're not moving. Yes, sir.
Question.
Yes.
If you're in a minimum till or no-till situation with hard ground, but you have enough highways with roots and earthworm roots and stuff like that, can that overcome that 200 psi?
Did everybody hear that question? No-till, strip till, minimum till? I can't answer that yet. Now, I don't want it to sound critical. I'm going to go over the tools that you can test for yourself and not have to listen to me. What I mean by that is you can check it, but in many cases, no, it won't. And this is why I'm not as favorable of no-till, because here's my point. Going back to the base saturation, 68 parking spots need to be calcium. Calcium, in my mind, is the mother of the soil, the mother of nutrients. What I mean about that is you can have a house, but if mom's there, it's now a home. She creates the environment. She's a fixer of all boo-boos. She's a finder of lost things. She gives a hug when something's going wrong. She's a referee. Calcium is that in the soil. Calcium is a good mother in the soil, but make no mistake, she's a big old gal. She is heavy. And if there's no tillage in the soil, and if the microbes aren't there because they can't breathe, calcium starts moving down and moving down. And what we see in no-till situations, the longer that has been without tillage and without microbes, we'll do an inch-by-inch soil test, where we'll test the top inch, the second inch, the third inch, and we'll find that there'll be very little calcium in inch 1, inch 2, inch 3. Where do most seeds start their life? Inch 1, inch 2, inch 3. If there's no calcium there, there's going to be very few microbes there, because microbes need calcium for their physical structure, just like we do for our bones and teeth. If you're curious, when that probe is going in, and you're doing a 0 to 6, what we have found, the longer, not all the time, but in most no-till or minimum till areas, the 4th, 5th, and 6th inch is where most of the calcium is at. When you have a deficiency of available calcium, when I say available calcium, just like phosphorus, it's got to have oxygen. If you have a deficiency of available calcium, the plant will go I gotta have calcium, I gotta have structure, I gotta have physical integrity. Say, oh crap, there's always options. If the plant can't find calcium, it will grab potassium. Potassium is an electrolyte mineral. And what I mean by that is electrically active. And if I was potassium, I'd say, oh, I'm potassium, I need everybody's water. Grab everybody's water, hang on to it. I can't use all this water, but I'm going to take it because I'm potassium, that's what I do. The more water a plant takes in because of an excess of potassium, the lower the sugar content is, the higher the kilocide application rates are. I should clarify kilocide, it's a technical term. If you've forgotten Latin from college, side, the suffix CIDE means to kill, death, destruction, subtraction, deduction, ending. The sides, fungicide, kills more than just detrimental fungus. It kills your good bugs, some of them. The herbicide will kill a weed, but it's doggone sure going to kill some of your beneficial workers, the microbes in the soil. Insecticides and pesticides will also kill microbes and fungi of the beneficial side. And as those die off, you just started killing the carbon dioxide generator that gives 2 ingredients for the plant to make sugar. The other, and I'm going to piece by piece answer your question. If I don't get to it, throw something at me and you'll doggone sure get my attention. When you start looking at these numbers, all of these things will start adding up. But if the potassium is too high, you're going to have a lot more water, you're going to dilute the sugar content, and now all of a sudden you have the potential of buying more chemical. So when you look at fungicide, herbicide, insecticide, pesticide, we could just as well throw in suicide and homicide. They're needed, I get it, but you don't have to react to symptoms all the time. In Washington State a few weeks ago, I had a guy raise his hand, he's like, so you're telling me that we can grow crops without chemicals? I said, I am so sorry that your friends and acquaintances have gotten you to believe that it's impossible. We grow organic. Here's a beautiful thing. Beautiful yet double-edged sword. When you're a no-till farmer and you leave that soil armor, that protectant, that residue, and you take that into your soil lab and you send that off for analysis, much of what they call soil organic matter is still residue, and there is a difference. Soil organic matter is within the soil and has been digested once by microbes. What's showing up on all these soil tests is residue. And the residue is last year's crop, and this is going to sound incredibly technical. Doesn't matter if it was a corn bean rotation or a bean corn or a wheat corn or whatever it is, most all of these plants want to be made of the same stuff. When you lay that on top and the sun comes back into our hemisphere and the infrared and the ultraviolet start pounding down on that, they will start oxidizing and you will lose every element eventually. Within 1 year, you're probably going to lose up to 60 to 70% of the beneficial nutrients that are in that residue. Now, in conjunction with that, the groups that are pushing for no-till, they'll say, don't you till your soil. You're going to lose all that carbon. It's gonna go up, up, leave you. Here's a little chemistry. The carbon that's in your plant that's known as residue or fodder or stubble, when the sun hits it, it will oxidize and leave you. If the microbes are in the soil and they've taken that carbon and made carbon dioxide, this is 1.5 times heavier than atmospheric air. It won't go anywhere. So when they tell you, don't till your soil, you're going to kill all the microbes, you're going to lose all your carbon, and you're going to have a disaster. Believe what you will, but if you know enough chemistry, without being a chemist, you can come back and talk to them. Some of the numbers that we look at in that middle box are something new to most growers. If you haven't checked or asked for a carbon to nitrogen ratio on your soil test, and you have to ask for it specifically, they won't give it to you. Now, if you talk to a university professor, you say, yeah, I had this goofball from South Dakota talking about carbon to nitrogen. Never really heard much about it, and what do you guys think of that? What's the university think of that? And the university would say, oh, you probably have 8 times more carbon than nitrogen in your soil. And that's line number 1, and that's what most soils are, is an 8-to-1 carbon to nitrogen. There's an article, and this is information that we have gotten from microbiologists that we hired years ago to figure out what microbes like. There's an article that the NRCS has put out that mimicked our numbers almost identical. And of course, I found out about this research data that the NRCS already paid for after we spent $169,000 learning it. That's just my luck. We spent the money, you can benefit from it, but the NRCS carbon and nitrogen sheet will talk about that. So the agronomist will say, oh, you got 8 times more carbon than nitrogen. If you're at the university and you come out of the chemist or the agronomist's office, you look down the hallway and you see the microbiology lab, it's like, maybe I go talk to them, because CO2, what microbes exhale, is part of what the plant needs to create its immunity, fuel, and productivity. So you go to the microbiologist and say carbon and nitrogen. What do you guys know about it? And the microbiologist say, which door did you come in? Did you come in this door, or did you come in past the agronomist? If you came in past the agronomist, he probably tested an 8-to-1 again. He said an 8-to-1 just gets microbes awake. It just gets them conscious. They don't work. They don't breed. They don't benefit you. We know people like this. I have people like this in my family. They're just there taking up space. The microbiologist would say you need, for healthy microbial activity, you need a 16-to-1 carbon to nitrogen. The reason I say this, and this is part of your answer, and thank you for that, I'm glad you're here. If you till your soil because you've got compaction, and compaction is anything over 150. If you're over 200, the microbes have suffocated. They're not doing anything for you at 200. Uh-oh, yes, sir.
At what depth? At what depth?
Yes, at what depth? Yes.
Inch depth.
What?
Well, where do we hit that 200 level at? You know, we may have 4 or 5 inches of very Good reading, 120 pounds. Yeah.
Did everybody, thank you for keeping me honest. He goes, what depth? What depth do you want your roots? What depth do you want your microbes? And here's the other thing. Sinking air is designed to push air into the soil. Anybody got an idea what the pressure should be for that atmospheric air to get pushed into the microbes to enjoy it? Yes, 100 to 150. Huh, must just be coincidence. The deeper you can get this economically, the bigger the breath of air, the bigger the count of microbes that can breathe, the more CO2 that is given to the plant to make sugar, the more success you will appreciate. Am I answering your question? Okay. Oh.
What do you do with clay soil?
What do we do in a clay soil? You may need, okay, clay soils. What do you do in a clay soil? Calcium is the mom. If she doesn't have enough oxygen and microbes, she can't break up a fight. What I mean by that is, if you have compacted soil, it's normally high magnesium. Magnesium, if that name were given to people, my brother would have been called magnesium because he just couldn't contain himself and he's always causing trouble. If you have excess magnesium, you're talking for your neighbor. If your neighbor has excess magnesium, you're going to see you have excess nitrogen in your soil because magnesium electrically grabs onto nitrogen. So if I was magnesium, I'd say, ooh, all this air, all this nitrogen, grab it all. And it will hang on to it. If you can get some good available calcium, you're going to introduce mom to the problem, and the calcium, mom will grab magnesium and say, hey, let go of that nitrogen. And you'll see the nitrogen leave the soil that was tied up, unavailable, and go to the plant. Now you have fixed some of your nitrogen needs, but you have to have microbes, you have to have oxygen, and those microbes have to have something to eat. Anybody got an idea what they want to eat? But chances are your neighbor's plants aren't making enough sugar to put down to the roots. And the microbes are either starving or suffocating. You gotta put some liquid carbon back out. That liquid carbon, and here comes the other thing, the neighbor that isn't here that has a high pH soil over 7 has no hydrogen in his profile because he has a low carbon and oxygen. You want to get hydrogen back in your neighbor's field, add some carbon and oxygen. So when they talk about liquid carbon, there's also oxygen in there. Huh. Why would they give us something that actually makes sense, or give us the option to buy something that actually starts building the essence of the plant? So when we look at the pressure, this gets back to the question statement over here. If you're over 200 psi and you're not tilling your soil because you're worried about killing the microbes, they're not doing anything anyway. They can't breathe. If you don't have a 16:1 carbon and nitrogen, you're not going to kill anything because they're freaking starved. They need a little bit of grocery. The next number is 300 psi. At 300 psi, up to 300, you don't have any microbes there to speak of, but a feeder root can still push and fight through. And many times, when your neighbor gets this delivered, he's probably going to call you and say, hey, should we test this soil when it's wet or when it's dry? And your accurate answer would be yes. And he will say, you're not that funny. When you test soil when it's wet, it's soft and mellow. If you test it with high mag, it's hard. Now, tough question. Don't overthink this for more than a second, but if the soil is wet and soft, and when it's dry, it crusts over and cakes over and gets hard, you have a deficiency. Hydrogen and oxygen. The pH is over 7. You already know you have a hydrogen deficiency because they told you that on your test. You check the penetrometer, you now know you have an oxygen deficiency. If you're low in carbon, you have another hydrogen deficiency. All of this works together almost like it was part of the 6-state plan. I'm sure it's coincidence. This has worked forever until the human race got involved and greed came into effect. A lot of guys say, well, this kind of makes sense. I like this because everything else we're looking at doesn't give us many options. What do we start doing? I said, don't do anything until you know where you're at. Breathing is important. Something to think about. If you have high magnesium and that soil's tight, the rain comes, the soil mellows out, and the microbes do the puffing. It's like, oh, this is awesome. And they're dancing, they're doing it, making it happen, and they're giving off CO2. It dries out and you get a light crust of soil. There's a crust, maybe just a paper-thin crust. We've already established that everything wants oxygen. Everything needs oxygen. To look at this differently, if you look at air and heartbeat and food and romance, none of them are considered or thought of as important until you're not getting one of them. So if you see somebody laying on the floor that's purple, and you can tell they're probably not getting air, it's like, you want a cheeseburger? If he could breathe, it's like, oh, a cheeseburger, I want to breathe. Point being is that soil seals over because of a lack of calcium, because mom's a big old gal and has gone downstairs into the 4th, 5th, and 6th inch. Carbon dioxide, when that soil seals off, when you lose 1 molecule of oxygen from carbon dioxide, you get carbon monoxide. Let's go one step further. That soil seals off for a while, and the oxygen is a fight. To give you an idea, if this room got sealed off and there was no new air, the smart guys would go, he said, CO2 is heavier than air. I'm going to get on a table because CO2 is heavy. Somebody else will be choking somebody else out. If they're not breathing, that's more air for me. There's going to be probably 70 different activities for survival. When that soil seals off, the longer it seals off, the tighter it seals off. You lose 1 oxygen, it goes from carbon dioxide to carbon monoxide. You lose the last mole of oxygen, you have carbon in an airless environment, and all of a sudden the plants are drooping. Well, let's give it a shot of nitrogen. That's worked for 20 years. Carbon and nitrogen in an airless environment can form and has the ability to form cyanide. Welcome to North American agriculture. And how do we know this? We've taken meters and we have tested carbon monoxide meters, cyanide meters. And when we show them the numbers, this is usually in perennial no-till crops like trees, they'll go, huh, that could be why our trees aren't doing so well. From 200 to 300 PSI in the soil, wet or dry, a root is still pushing through, but it's naked. What I mean by that is, if it's over 200 PSI, the microbes are like, here's our union card, not working. We're spored off, we're dormant, we're not doing anything. That root says, I gotta grow. Just got a shot of rain, soil mellowed out, I'm gonna go through it. as the soil dries up, you see where that pinched off and gets smaller. So my point being is that question that you asked is a multi-level, it's a great question, and I'm trying to answer it step by step. But when you see the roots go down, and if your neighbor buys this and says, and you show him how to use it, and he says, yeah, you don't get to use this anymore. I said, what are you dirty dog? You got a sand shovel, dig up some roots. The roots will tell you what's going on. Many times in your neighbor's field, those roots will go down 2, 3, 4 inches and then go lateral. That's 300 PSI or more. Or the roots will go down and all of a sudden get smaller and keep growing. That has become 300 PSI. The weeds that are just a plant growing out of place, many years ago I tested and tested and tested. I went into fields and I would see where we had a big patch of dirty, rotten, nasty pigweed or Canada thistle or musk thistle, it doesn't matter what. I'd take soil tests out of that. I'd take soil tests from where there were no weeds and there's good crop. And I'd take a look at them and say, aha, there's no stinking difference on the soil test. So I'd test a different lab, a different field, a different crop, a different county, in a different state, and I'd look at the numbers and say, aha, there's still no difference in the mineral. Until I realized that the minerals only make up 45% of healthy soil. When we started finding out and looking at the carbon to nitrogen, all of a sudden the choir sings. And when we get over 16 to 1 carbon to nitrogen, there's no more talk of chemical resistant weeds or super weeds. If one of your neighbors has a super weed, be polite, be respectful, but just tell him he's got super screwed up soil. There's an excess of potassium and there's an excess of nitrogen in that soil that is growing the weed, and they have an excess of compaction. Many of these big, white, hard, tap-rooted weeds can push through up to 800 pounds of pressure. And what they're trying to do, they're looking for moms. Think about though, if you ever dug up one of those big, heavy, white, tap-rooted weeds, it's big and white. White is calcium. It has gone down, grabbed the calcium, it's trying to bring it back up. It's trying to work for you. It's a scout. It's a mechanic. It's like, no, I'm not out of place. I'm trying to open up the soil. I'm trying to bring up some calcium. And here comes the spray boom with the homicide in it. It's like, you just killed me before I got my work done. I get you got to kill it. But pay attention to what it's trying to do. And the more times that spray boom has to go across that field, the lower the sugar content of that plant is. The weedier that field is, the more important it is for you to put some liquid carbon on that field. And when I say liquid carbon, what I'm talking about is there's 3 forms of carbon that need to be in your soil. The quickest return on your investment is some sort of liquid carbon. Personally, me, I'm old-fashioned. We've tested a lot of different carbons, liquid humics, liquid humates. The numbers look good on the label, but many times their processing to get it to a liquid form has ingredients in that the microbes don't like. It's like going to a party and seeing the punch bowl, grabbing a glass and a dipper, and you're just ready to dip in, and so all of a sudden there's a turd laying in there. Like, I guess I'm not going to have punch. The carbon has to be in what they call bioavailable form. What I like about natural, simple, and these guys hate when I talk about this, but sugar cane is a plant. The sugar and the molasses has been extracted from that plant. It has been grown by a plant and fueled by microbes, do you think there could be an easy assimilation back to the soil, to another plant? And that answer is yes. The less synthetic crap we can have to deal with, the better Mother Nature will appreciate that. Make no mistake, the earth is female. And when I say female, I think anybody could possibly finish this statement. If mama isn't happy, we all know it. You guys get home, and if your wife is standing with her hands on her hips and one foot out, that's not a honeymoon sign. Something's going wrong, or she's letting me know. That's nonverbal communication. If the plant doesn't make sugar, the products that you're using were not appreciated by the microbes. If your soil pH is over 7, you have a carbon and oxygen deficiency. Carbon and oxygen are the only things that will fix this. And I'm guessing that somebody has told you that if your neighbor's pH is over 7, you need to apply Tiger 90, gypsum, elemental sulfur. I can't hear it, I don't know sign language, Bob, I'm sorry.
You had 5 when I stood up, and I only had 3.
Okay.
You should know this after 3 days.
Slow but I'm consistent.
I know.
I just lost what I was talking about.
Sulfur 90.
They want you to spread Tiger 90, elemental sulfur, gypsum. Said sulfur is wonderful for lowering the pH of your soil. And they're kind of right. What I mean by that is, here comes this chemistry thing. You have sulfur that is an S. You have a sulfate that is SO4. There's that oxygen again. If you put out gypsum, which is calcium sulfate, or elemental sulfur, or Tiger 90, it eventually will grab an oxygen to make a sulfate. And then, when you get a rain, you add water. When you add sulfate and water together, you get battery acid. I wonder how the microbes feel about getting sprayed in the face with battery acid every morning. The gypsum, the Tiger 90, the sulfur will drop the pH for your soil for a short period of time, but it will never, ever fix it. The reason it won't fix it is because you got to go back to the basic building blocks. The reason that pH is high, because you're short of carbon and oxygen. The chemists that are studying and telling us all this information forgot about organic chemistry. And organic chemistry is a study of carbon and everything hooked to carbon. And I think if carbon were a human, she'd possibly be a prostitute, because carbon will hook up with anything. Say, oh, you're a good-looking element, come on. Oh, this, nitrogen, oxygen, anything. Carbon can make more relationships than all the rest of the nutrients put together. If you have carbon, you gotta have oxygen. Because carbon's a little bit sleazy and she'll make a bad choice. Give her oxygen to hook up with, and now you've got something that the plant can grow from. Comments? Questions? Did I answer your question yet? Probably not.
Yeah, probably.
Probably. Yes, sir.
They say you want pH of 7 for soybeans to get the maximum benefit, nutrients. Is that not right?
Who are they?
Yeah, who said that?
Sure, like
Huh. everything that we have seen and all the testing we have done has been independent. I've read tests like this. I've been involved in tests like this. If I didn't know, we'd take it to our research greenhouse, we would take it to our research farm, and we'd test it ourselves. Whoever they are, I would love to talk to them. Because everything we have seen is everything becomes more financially profitable for you when you get under 7. And if you'd like to ask a question, at 7, your soil has virtually no hydrogen. If the soil doesn't have hydrogen, how can the plant make sugar? It's like you went home and say, well, we don't have any chocolate chip cookies, sweetheart, but can you make me chocolate chip cookies? She'll say, no. I have to have the ingredients. The fertilizer companies have worked very hard, along with the chemical companies, along with the seed companies, to keep us down. So I will politely and respectfully say they are not giving you accurate information. But do your own test. God, I'm glad you're here. Look at your soils of your neighbors that may be over 7 and compare it to something that's under 7. And then you'll know. That's this chemistry thing. Once you understand the components, the ingredients, you can do your own research. And here's the beautiful thing. Knowledge is power. Power rules the world. The more you know, the less you have to count on somebody else. And if you're going to bet on somebody, you're going to bet on yourself. How am I doing so far? That isn't really I don't know if I can ever make you happy. Did I answer your question? Okay. Yes, sir.
Your thoughts on mechanical aeration?
Sorry, I'm deaf.
Your thoughts on mechanical aeration?
Mechanical aeration. This is just my opinion. But if you've got compaction in your soil, it's a fight. The magnesium is causing a fight. And at some point in time, if you want air, if you want sugar, if you want microbes, you got to break up the fight so you get some air in there. A lot of the strip tillers that used to be no-tillers, I said, well, you're a no-tiller before, you're a strip tiller now. And they said, yeah, you and your little compaction meter. It says, we strip till. It's going to be nice and soft and mellow all year long. We're in that 6-8 inch slot. I said, I'll bet you a burger and fries and a new pair of boots that by the middle of June, you won't be able to tell the difference with this. If your magnesium's over 15, 16%. So we know where the slot is because that's where the stinking corn is. But close your eyes and check, you won't find it. Mechanical tillage is good. It's fantastic, but don't just do it over and over and over and over. Minimum tillage, intelligent tillage, common sense. Here's my point. If you can open up that soil and get some carbon to the microbes, and when I say liquid carbon, whatever form you choose, but it's got to be liquid because it can be easily assimilated by the microbe, so it can take that liquid and turn it to a gas. And that CO2 is heavier than air and has to be exhaled, 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 exhaled up to get back into the plant. So to go back to your question, depending on where the leaves are, the deeper the aerobic zone, the higher the microbial count, the more carbon that soil and the microbes have to push that CO2 up so it can get sucked back into the leaf, the stomata, the cell of the leaf, and now you got photosynthesis starting to happen. The carbon has stabilized the hydrogen, the plant can now make sugar, and now you can say no to a fungicide. And I'll tell you exactly the numbers that you can say no to this afternoon after lunch. Did I answer your question?
I should have been more exact. I'm referring more to rotary, like a Gentile system or a curve buster system that's poking holes in the ground, that type of mechanical aeration, not tillage. Conventional tillage.
Go ahead.
What we did, my dad had CRP, just under 1,000 acres of CRP. He was getting elderly, and I went out and started checking. After 13 years, a 10-year program, we renewed it for another 3. After 13 years of no-till, after 13 years of no traffic, just cutting it off every 3 years, I started checking. Had a hard pan at 1.5 inches. Had a hard pan at 3. Had a hard pan at 6. I went to spraying our nutrients and all the good stuff, and I didn't see much of a response. Personally, we went in with an airway, just poked holes, 7 inches deep, 7 inches apart. In 2 years, we completely turned that soil and those plants around, that I will get to the numbers. My point being is there's going to be more tools that I'm going to show after lunch. Please know where you're starting. Measure and manage. And management is easier if you know where you started. A lot of guys say, well, I'm not going to buy any more nitrogen because the sugar makes sense. It's like, find out where you're at first. This farming deal is expensive. Find out your numbers. Air is the most important. 100 to 150. Bob's going to rip me off the front of the room here, so there's more information afterwards. I hope this has been useful so far, but if he lets me back, we're not done yet.
All right, now, it's phenomenal, he said great growth too. So if you look at the Great Lakes region, that's how we deem that, Michigan, Indiana, Ohio, for a while, it was Ontario, Canada. We don't go there anymore because we're growing so big. It takes, 3 days to get a truck out to Ontario and back, and from, if you don't know, all your fertilizer products that you receive get made in LaSalle, Illinois, and so on. It's the whole Great Lakes region they service. So it's Michigan, Indiana, Illinois, the northern part of Kentucky, and there's a couple other states that aren't part of the Great Lakes region. But if you look at what we've done in the Great Lakes region, we've had 1 year where we went backwards, 2022 to 2023, or the season of 23, and that's where I'm on Bob Jenna with 2.0. As I said, I worked for QLF for a bit, and I left QLF for a bit. I still had boys at home that were playing sports, and I wasn't home enough, so I took a little sabbatical. I've been back this is my 4th season back, I think, 3rd season back, and so on, and we continue to grow with your help. We're gaining popularity. What Glenn teaches about, sugars and carbon, that's us. The research that Anthony and we partner up with across the U.S., third-party researchers and so on, we're showing good results. We don't win every time, but we do help. There are other factors. Up in West Michigan this year, we went through drought. We had boost on some ground that we harvested 38 bushel corn. Something to talk about, right? So things need to happen too. Biology's got to be happy in water. So I just want to share that to say thank you for your growth. Steve is a phenomenal person. He comes from roots that they were using before they sold and his dad passed. They were using just about 800 tons of our products, QLF products, on their farm a year. So he's got belief. So he's just a great asset also to QLF and our team. And then, the addition of Connor, too, in the Great Lakes region. Connor comes from another brand of fertilizer, and we kept running into each other, so he came over to what we call the dark side, the brown side, right? So he's been a great addition to our team, too. So I'm done. We're going to go till about 10-ish to 2, and so on. Then we'll answer more questions. We will get you out of here at 2 o'clock sharp, I promise. Mr. Rabenburg, you're up again.
Anybody want to quit and leave? Leave now or forever hold your peace. I didn't see any no-tillers in here, because if you were truly a no-tiller, you would have pulled your shirt up, flopped your food on your stomach, and let it osmotically soak in. I'm not trying to be a smart jack, I'm not picking on anybody, but I want everybody to be successful, and somebody has to give the other side of what you're probably going to see. 10 years ago, we were the red-headed stepchild, we were the freak. Now we've kind of turned into the prom queen, and that kind of spooks me, because I think I got a pretty good idea whenever your kid wants to do the prom queen if he gets a chance. But the information, if it isn't important, in other words, if it isn't costing you money, don't worry about it. We're awful busy, we're getting a lot of calls. I got a question out in the lobby. Guy walks in and goes, "What are you selling?" I said, "That's a great question. I'm selling the idea that you guys can learn and figure things out on your own. I'm selling the idea to do your own testing. I'm selling the idea of talk to the people that are supplying you products and start asking them questions. Questions are sometimes the most important form of communication. I'm guessing a couple people may buy nitrogen. And everybody say, how do we get rid of our nitrogen? If you've got too high of a nitrogen bill, it's probably because you have too low of a carbon and oxygen sugar content. You got to have one or the other. If you're going to cut back your nitrogen, you better put some carbon out there, otherwise it'll hurt. And the limp won't go away right away. Another way of looking at your nitrogen, if you're at that 100 to 150 psi, you're going to allow air. And the atmospheric nitrogen looks like that. It's not available to the plant. You have to have microbes in the soil break this down. Well, so we got to have microbes working on this. There's two forms of nitrogen that you can have. If you have over 200 psi compaction, that microbe is not going to form nitrate nitrogen for you. Looking at all the cobs that didn't finish out on the end, the other nitrogen, NH4, there's that hydrogen again. Nitrate, ammoniacal. The plant will use less nitrate than ammoniacal. This is your vegetative root, stem, and leaf, the first nitrogen. Your ammoniacal, NH4, is your finisher, the cob filler, the pod filler. Sometimes your neighbor that has all the other problems has beans that look bushy and beautiful and fantastic. He's got all kinds of nitrate that grow a big, bushy, almost a shrub. But when it defoliates and the combine goes through, you now can say, hi, the pH was too high. The plant had no hydrogen. The microbes had no hydrogen. I bet you don't even have hydrogen on the base saturation or soil test. And you'll go, how did you know that? Because you had big bushy plants that didn't amount to a crap. When you're looking at your soil test that only makes up 45% of the plant, rather than just total N, look at nitrate and ammoniated. It will tell you more than they want you to know. If the nitrate and ammoniacal, or NH4, are close to being balanced, you have pretty good biological soil. The closer they are to equal, things are going well. The soil test tells us more and what they want us to know. With that, I'm jumping around on the sheet a little bit. We're going to go up to what a healthy plant is made of. There's two little slivers of 3%. And I'm going to start with the smallest inclusions of what makes up a healthy plant, which you're going to realize the smallest portion or component of the plant makes up your biggest input. Something's not right. What am I selling? The opportunity, the invitation to think about stuff and question the people you're working with, and maybe take a look at putting some products to the soil or to the plant with some common sense. So 3% of the plant on a dry matter basis, and what I mean by that, if you check a corn or a bean or a wheat or a grass or an alfalfa or a peach or a plum or whatever, most of them are 80% water in the field. Water's a variable, we all know that. Get rid of it. We want dry matter. So these numbers are the 20% that make up the dry matter. This is the money of a good, healthy plant. These numbers are from a healthy plant. Now, if you haven't heard of these numbers before, they're relatively new numbers. The first place I saw these written were from a university professor from Yale, and he published the book in 1853. And I've talked to many different plant physiologists since then, and no one disagrees with these numbers. The university has kept this a secret for over 170 years. Oh, gal, whoa, we forgot. We probably should have told these guys what a plant is made of. I don't think it's a coincidence. So 3% of the plant is nitrogen. That 3% nitrogen makes up most people's budget. How do you want to get rid, and how can you get rid of a nitrogen bill? Number one, see if you can get air in the soil, because if air comes in the soil, 78% of that air is nitrogen. And if you're at 100 to 150 psi, and you have some food, some microbe food, some carbon-based food, and some oxygen, those microbes will make nitrate nitrogen. The carbon will help start lowering the pH, stabilize the hydrogen, and those microbes will make you ammoniacal nitrogen. And yes, I'm telepathic. I can already hear the questions you're thinking. How quick can this happen? How soon can we cut our nitrogen? I'm that good. You have to find out where you're at. This is a piece of equipment called a refractometer. If you've never used this or never seen it, it's because this is a fairly new invention too. This was invented in 1863. Many agronomists, many companies say, oh, refractometer, sugar meter. That is not accurate. You can't tell squat. It varies from the morning. It's higher in the afternoon, it's lower in the evening, it's even cloudy for 2 days. Doesn't show squat. That's no tool. And they're almost completely right, because it does vary, morning to afternoon, cloudy to sunshine. But the wine industry has been using this successfully for a lot of years. So you or your bride enjoy a glass of wine, they got to be at 22, 23, 24 bricks to get good wine. If you grew tomatoes or lemons or strawberries, the companies that buy tomatoes and sell different produce are now paying premiums on sugar. If you look, if anybody sells to an ethanol plant, and here's where the long-tailed cat in the rocking chair room gets going. If you look, the ethanol plant is buying corn to make ethanol. If you look at the chemistry of ethanol, carbon, oxygen, and hydrogen. You go to the pump, if you grab the premium, higher octane, you pay more. What if you guys could give a higher octane to the ethanol plant? You should get paid more. There's white corn growers I was down south of Springfield, they're getting up to $1 a bushel premium based on this. Sunkist that buys lemons, one of the first companies to pay premium on sugar content. There's more premiums that you guys can experience and appreciate than what most companies want you to know. But there's some other high-tech equipment that comes along with this that you have to have. And if you think this is a garlic press, you're exactly right. Take a few leaves, stuff them in the garlic press, do a quick little squeeze, 2 or 3 drops, close the lid, look at the light. The light will bend and refract through this prism of glass and show up on your screen. If you are 3, 4, or 5 bricks, that's B-R-I-X, you're probably growing a GMO corn. If you're under 8 bricks, plan on buying fungicide. Asian rust, many years ago, you guys probably remember it was a problem. Now there's other pathogens. The Iowa Soybean Council called us, says, can you come down and talk to us about Asian rust? So we get to the meeting and it's doctor this, doctor this, doctor. As usual, I am the dumbest guy in the room. And so they said, tell us what you know about Asian rust. I said, okay. So you guys are the doctors. Help me get started. Give me a couple things. What does Asian rust like? If Asian rust, and here's the other thing, I'm speaking about Asian rust, but any fungal disease, algae, fungus, mold, on the detrimental side, are all part of the same scumbag family. They all enjoy the same environment. And the university lead professor says, Iowa says, well, fungal diseases, algae molds, they like warm, and they like wet. Like, okay, what else? Well, that's all we know. And usually my mouth is traveling faster than my brain. It's like, well, we could have gotten an answer like that from an 8th grade science student. I'm now making friends. No matter what the fungal, algae, or mold disease you have that you're seeing on your neighbor's fields, it enjoys a low sugar content. If you're under 8 to 10 bricks of sugar, plan on buying a fungicide. You get up over 10 bricks of sugar, and you can have almost 99% certain and matter of fact that you don't need it. The detrimental disease-causing pathogenic fungus, Phytophthora, Rhizoctonia, Pythium, Verticillium wilt, pick your critter. None of them like sugar content.
What time of day is that? What time of day is that?
What time of the day is that? Yes. I don't mean to be a smart jack. 10, and thank you for that, 8 to 10 is the minimum. So, I'm glad you asked that. You're keeping me honest. If you're at 9 bricks during the peak of the day, and you check tomorrow morning, and you're at 6, which is usually bigger than what it'll change, you're probably going to get hit. So, the lowest point, sometimes we see 100% protection at 8, sometimes it takes 10 bricks, minimum. So, when you get to 8 or 10, you may only need 1. Something else, what does fungus, algae, and mold diseases not like? Doesn't like sugar. Is there sugar in molasses? The liquid carbon that they were talking about? Gee, can it be that simple? We have many certified organic growers that molasses or sugar sprayed on the leaves, it's eventually going to go down into the roots, but many times it will give protection if they're close to get through the pressure. You got to know where you're at. If you're at a 3 and you're spraying sugar and molasses on there, not going to do it. If you're at a 6 or a 7, you got a real good chance of getting it. So, any fungal disease, even tar spot, that just happened to blow up from South Africa or South America or somewhere. Here's the thing, there's over 1,300 pathogens in this air right now, right here, in all of our noses. Why aren't we sick? Because we have enough nutrients, we have enough energy, we have enough immunity that comes from the carbon in the food. QLF got their start giving molasses to livestock. And when I first heard that, it's like, that is so stupid. Why would you put molasses for livestock? In time I realized it's like, because the feed didn't have enough sugar to feed the 896 different microbes in the rumen, and when those microbes in the rumen are eating and breathing and partying, they create what they call bypass protein, which is the most efficient conversion and gain that livestock can have by putting a little bit of molasses in the feed. Brilliant. The poorer the feed was, the more the molasses you had to put in to get the desired result. It's the same thing on dirt. You gotta end up putting sugar on the soil in the form of some form that the microbes will enjoy it.
Plant stage, reproductive, vegetative, there is a different time and portion of the plant to take your Brixlet readings from, correct?
Can you give me just 2 minutes to catch up? I'm trying to keep up with
Brother.
A lot of pressure. There's a lot of pressure up here. Yes, okay. Thank you for that.
Sorry.
So, no. We've been this way all week. I am so glad today is the last day. Goodbye, Bob. No, it's been a lot of fun. A plant, when it's growing vegetatively, and this will be another thing that they don't tell you. When a plant is growing vegetatively, root, stem, and leaf, the form of nitrogen it wants is nitrate nitrogen. But keep in mind the plant, a healthy plant, only wants to be made up of 3% nitrogen. If that's your biggest input, you are short on carbon and oxygen. While this plant is growing vegetatively, the experts will call this anionically, is growing root, stem, and leaf. During the day, that plant is grabbing sunlight, getting a tan, making sugar, and at night, it pushes that sugar out the roots. It feeds the microbes. The microbes party and romance and honeymoon, break nutrients down, chew stuff up, make nitrate nitrogen, because there's air going in and out, because you got 100 pounds PSI of compaction, and the nitrogen they're forming, but as soon as your crop goes into reproduction, flowering, silking, tasseling, blossoming, the plant hangs onto that sugar up top, and it doesn't send it down to the roots, or a very small portion goes to the roots. Think about when most of your diseases, problems, and weed pressure are. Normally after flowering, silking, tasseling, blossoming. When the plant stops pushing sugar to the roots, if you don't have any carbon or oxygen in the soil, the microbes stop making CO2 because they don't have any food. When the CO2 stops, the sugar production stops, all of a sudden, boom, this drops. Here comes the spray boom, and here comes the fungicide. You can check all of this. Chemical resistant weeds, super weeds, do not enjoy 10 bricks of sugar or more. If you have over 5% potassium in your field, you will probably grow more weeds. If you're doing grid maps, look to see where the higher potassium levels are. You will have a lower yield. You will have a higher weed pressure in those areas. Potassium is the only mineral that I know of that got a nickname. Hot ash. If you have wood, cobs, grain, coal, whatever, in your stove, the heat, the fire will burn, you'll get BTUs off all this, and everything will oxidize and go up the chimney. When everything's burned out and the fire goes out, what do you have left in the bottom of that stove? Hot ash, potassium. If you've had a wood stove, you take those ashes and throw them out somewhere. When those ashes are hit the ground and slowly soak in, what do you start growing a lot of? Weeds. Weeds enjoy high potassium. Weeds enjoy high nitrogen. GMO crops are pushing you to the same extent. You're growing a crop, and please don't kill the messenger. You're growing a crop that has the same appetite as a weed. And you can prove that by checking the sugar content. Because most weeds won't grow at 10 bricks or more. There's a book that your neighbor will not have to buy. It's called When Weeds Talk. And we started years ago, we started looking at what weeds liked. You've seen this book, what weeds don't like. And what we find is every weed does not like calcium or phosphorus. It does not like carbon or oxygen. It does not like a balanced pH. It does not like a high sugar content. It does not like a lot of microbes in the soil, and it does not like a high sugar content. When you get your crop to 10 bricks of sugar, you're going to teach a little respect to the weeds, and they will bow down to you in a very humble manner, because you have now started to engineer an environment that they don't like. Yes, sir?
Could you just say what you just said again?
I don't think I can. It's just kind of spews.
Weeds don't like that.
When you create an environment to grow food, and I'm not being anything but honest, I don't consider a GMO crop food because it isn't 10 bricks of sugar. Some guys will say, long answer, sorry. Some guys will say, well, wait. In Wyoming and Montana, a lot of the Native Americans will say, a lot of those weeds we use as medicine. I said, yes, you do. Do not confuse nutritional with medicinal. It's different. Create the environment for what you want to grow. The weeds have an appetite exactly opposite of what your crop does, unless it's genetically modified. And I've got nothing against GMO guys, I'm just telling you the truth. I'm just a messenger. Weeds enjoy a low sugar content, under 10. You're still not happy. You're killing me here. Well, what else can I give you? You're giving me that look like, come on, you're not telling me what do you want to know?
You said weeds don't like these things. What don't they like?
Weeds don't like calcium, available calcium. 68% base saturation calcium. Weeds don't like phosphorus. Phosphorus, not in the P1, not in the P2. Thank you, that's a really good question, I appreciate that. But P2O5. So calcium and phosphorus, weeds don't like that because those are the two most important minerals the plant needs to start making sugar. God, this all fits. Must be coincidence. And they don't like carbon and oxygen, or sugar, or molasses or a liquid carbon product. What you're doing is you're engineering your soil to grow things that make you money rather than cost you money. You good? Okay. Now, thank you for that. Any other questions, comments, or concerns? Okay, great.
So the varieties that are naturally resistant, and as far as the crop varieties that are naturally resistant, they naturally have a higher grit score, and that's why they're resistant, or they resist predators?
That question is probably more over my pay scale. The varieties that aren't susceptible to a fungus, I can't speak for genetics because we don't have a direct, honest one to compare or to isolate, but check the sugar content of that. Now, here's the other reason. I think this will help answer your question. Back in the 1900s when BT corn first came out, and it's not the genetic modification that's the problem, because the BT, that gene is just a bacillus gene from healthy soil. So think about that. They took the bacteria, the real, honest, good bacteria from healthy soil, and injected that in the seed. It's like, well, we'll sell this to you for the rest of your life. And when you order your corn, assume the position so they can get a good shot at you. The Roundup Ready gene also came from the beneficial bacteria of the soil. Huh. What if we got the soil to work better? With this, when we're looking at sugar content, there's a lot of things we haven't highlighted, but we've highlighted every weed